If you've been following these videos in order, then I have just ruined your favorite type of mathematics, just the simplest of counting things up. You're welcome. Going on, let's start looking at the other techniques we can use to study the big numbers, and we're going to talk about scaling and estimations. Starting off with scaling, we're going to take Earth and shrink it down to the size of an M&M, and with our Earth-size M&M, remember that's that 6,000 kilometer radius, compressed down. Let's grow up and see how big the rest of the universe is on this billionth scale. The moon will be about 38 centimeters away, a little more than a foot between the M&M Earth and our nearest celestial object, the moon. The sun, on this scale, will be about 150 meters away, a little more than the distance from the photographer across this lake. Those of you look carefully, you can see, here's me in my office waving. All right. The sun itself will be about a meter in diameter. So Earth's that tiny M&M, the sun, meter big in size. Keep expanding out. Neptune, starting it to the outer edges of the solar system, is 4.5 kilometers away. A doable jog. Some of you like to do 5K runs all the time. It's not unreasonable. 30 minutes, hour, depending on your comfort level. Our nearest stellar neighbor is a mere 40,000 kilometers away. Or, on our scale here, about one lap around planet Earth. So, once again, we are trying to shrink these numbers down just to get an idea of just how big the universe is. This is our nearest neighbor. That is an Earth the size of an M&M. And just to get to the nearest star, we need to do one lap around the physical planet on this scale. Let's go ahead and try a guesstimation method. We'll make this a question. You guys can work it out first, but let's read this out. We're going to say the moon is 384,400 kilometers away from Earth, and we're going to ride a jet aircraft going at about 800 kilometers an hour and say, how long does it take to get there? Well, if you are familiar with the Apollo missions, you can start using that as a way to start estimating things. And the Apollo missions took a few days to reach the moon. The mission itself, the total mission of leaving Earth coming back, was around a week. So with that in your mind, do you think a rocket ship is going faster than a jet aircraft? Definitely. So it takes the jet aircraft about a week to get to the moon and back. Then our jet aircraft is definitely going to be slower. So we can immediately cross out A and B. Just don't need them. And that leaves us with this range of, is it 3 weeks or 2 months? And how do we get there? Well, you could pull out a calculator, or you could try guesstimations. And this is where you're going to round the numbers in a smart, intelligent way. Take the moon, that 384,000 kilometers away. We'll call it 400,000 kilometers. It's an easy rounding up number. So we round this up to 400,000. The speed, how fast is our jet aircraft moving? Well, it was 800 kilometers an hour. Well, I'm going to round that up to a nice even 1,000. We're going to say the jet aircraft is going 1,000 kilometers an hour. Right? So I'm making the aircraft go faster. And you can already see from the scale here, if this is 400,000 versus 1,000, I'm going to need a lot of hours to get there. So I'm going to change the units. And I'm going to say, well, if we go 1,000 kilometers in 1 hour, well, we're going to go 24,000 kilometers in a day. All right, we're getting there. That means our jet is going to travel 100,000 kilometers every 4 days. If we jump in there at our approximate speeds here, every day we've traveled about 100,000 kilometers. So with 4 days of traveling time, how many times do we have to do 4 days like this? Well, 4 more times. So the time to get to moon, by our estimates, will be 4 times of 4-day trips, which gets us to 16 days. So we expect that our answer is going to be C, about 3 weeks. And think about our estimates here. We estimated the speed faster than it truly is. So we would expect the time to be less than it truly is. Instead of using a guesstimation method, we could just compute this out. And we could say that the distance is equal to the speed or the velocity of travel at times the time. And writing that in variable notations, I'd say the distance equals speed times time. Well, we know the distance. That's just the distance to the moon. And our velocity will be that 800 kilometers an hour. So isolate the time. Time equals the distance traveled divided by the speed, and plug that into your calculator. 384,400 kilometers divided by 800 kilometers an hour. And you'll get 480.5 hours. I don't really know what 480.5 hours is, but I know how to convert it into days. I'll just take that same number and multiply by 1 day. And to make sure that everything's happy, 1 day is 24 hours. So the hour unit will cancel out, and I'm left with the days estimates. So our travel time to the moon is going to be, in our jet aircraft, 20.02 days, which is just shy of being 3 weeks long. So there you have it, how we've used a guesstimation route. We just use logical values that we could round to get us in the right ballpark, and the explicit calculation. A recurring theme is we don't need the calculators here.